Now we're going to get into slightly more difficult ones, but it's all still going to be the same. It's going to be adding series and adding parallels together. So when I look at this circuit, I have these two resistors, 100 and a 250, in parallel, and then I have these two resistors, a 350 and a 200, in parallel, but together they are in series with each other. So the first thing I'm going to want to do is collapse this into one resistor, then collapse this into one resistor. So remember that when I put them in parallel, I'm going to have 1 over my RT is equal to 1 over 100 plus 1 over 250. And so I'm going to do in my calculator 100 inverse plus 250 inverse, and then inverse my answer, and I get a total resistance of 71.4 for those two resistors. So if I redraw my circuit down here, I'm going to come down into that first resistor, which would be 71.4. Now I'm going to put these two together to create a second resistor here. They are also in parallel, so I'm going to say 1 over RT equals 1 over 350 plus 1 over 200. So 350 inverse plus 200 inverse, and then flip that one more time, and I get a total resistance of 127.3 for those, so 127.3. Coming back around to my battery, 24 volts over here, and now I have two resistors that are in series with each other. So if I were to replace those two resistors with one resistor, then that resistor would have a value of a series circuit where R1 plus R2 is equal to my total resistance. So 71.4 plus 127.2 is equal to my RT. And that comes out to be 198.4 ohms. 198.4 ohms. And that is the answer to what the total equivalent resistance of this circuit would be.